Okay, so we'll just say the T is between A and B, and since it's a race, they have to run the same distance. So if we integrate the speed for the first athlete, that should equal this for the second athlete. Now that's the same limits. So that means AB V1T minus V2T dt equals 0. And if we divide by B minus A, then this becomes the average. So that means there exists a C in between AB. So that means then that B1C minus B2C equals the average, which means that B1C equals B2C. Okay. 145. Two mountain climbers start their climb at base camp, taking two different routes, one steeper than the other, and arrive at the peak at the same time. Is it necessary true that at some point both climbers increase in altitude at the same rate? Okay, is it necessary true that at some point both climbers increase in altitude at the same rate? So that is, does H dash 1 equal H dash 2C, the derivative? So two mountain climbers start the climb at base camp, taking two different routes, one steeper than the other, and arrive at the peak at the same time. So we'll say the time again is this. So I think this is it's the same. It's exactly the same, but just replace V1 with H1 derivative and V2 with H2 derivative. Yeah, it's the same, isn't it? By integrating H1 derivative, yeah, I think this is the same. Just, yeah, it's the same. It's the same. Okay, to get on a certain toll road, a driver has to take a card that lists the mile entrance point. The card also has a timestamp. When going to pay the toll at the exit, the driver is surprised to read a speeding ticket along with the toll. Explain how could this happen? Okay, well this is actually, I know this, they do this in Poland actually. Um so um what do they want us to say exactly here? Um 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 so I think the way we want to do this is you can in 146 say B2T is something above the speed limit. It's a constant function, which is some number greater than or equal to the speed limit. And let's say this V2 imagined car, we'll call it a ghost car, arrives at the same time and leaves at the same time, then just like question 144 implies, there exists a C such that the V1, and that could be your car, C equals V2C, which equals the constant, which is greater than the speed limit. Yeah. So if you leave, so in other words, if you leave and arrive at the same time as the illegal ghost car, then that implies you must have you traveled at that constant speed at least once. Okay. Okay, set f(x) equals that. Find f derivative 2 and the average value. Okay. Do they, so what way would they like us to do this? I mean, maybe of interest I could integrate this, so that would be t minus t squared over 2, 1 to x. So that would be x minus x squared over 2 minus 1 plus a half. So then they want f derivative of 2, which you can see would go right back 1 minus x, but at 2. So you can see it's exactly this, but still at 2. So that would be 1 minus 2, which equals minus 1. And then we want the average of f derivative over 1 to 2. So again, you can show it as an integration. It'll be 1 over 2. Let me just highlight this first answer. Okay. I want to make that color a bit darker. 1 over 2 minus 1, and then we integrate f derivative t dt, which actually is just going to be f of 2 minus f of 1 over 2 minus 1. F of 2 we've already worked out, it's minus 1. And f of 1 we can see would be 0. So it's just going to be minus a half. Let's check the answer here. 147. Minus 1 and minus a half. Yeah, minus 1 and minus a half. Let me just make this color a little bit darker. I guess that's a bit better. Okay, let's get us started on exercise 5.3.